we have the Doctors In session, and it's going to be moderated by Dr. Chris Moen, the past and current Chief Medical Officer of the Choroideremia Research Foundation, past president, past board member, past vice president, and all-around good guy. So thank you very much, Chris. Thanks for everybody coming, and he's going to introduce our esteemed doctors to my left.
Where are we here? Can y'all hear me okay? Yeah. All right, great. Good afternoon, everybody. How are we all doing today? All right, we have plenty of energy because this is an interactive session, right? So I hope you all are having a great morning and afternoon here, and that you have enjoyed the experience so far. This is, as Neil mentioned, the Doctor Is In session. This is the opportunity for those of you in the audience who have been bombarded with information over the last 2 days, as well as information during, physicians' appointments and things you found on the internet and such, to sort of take some time and come up with some questions, and for us to be able to try to answer those for you. So there will be 2 runners in the room like we have with the rest of our sessions, bringing microphones around. I would ask, if possible, try to keep your answers reasonably succinct, as there may be many others in the room who may have questions as well today. We're really excited. This is always a really great session. We may not have answers to all of your questions, but we will certainly do the best we can. So I want to say, first of all, thank you all for being here, and certainly thank you to our esteemed panelists who have volunteered to participate in this session today. And bear with me as I read through their introduction. So our first panelist is Dr. Ajoy Vincent. Dr. Vincent travels from Toronto, Ontario, Canada, where he serves as staff ophthalmologist with the Hospital for Sick Children. Dr. Vincent is a passionate and dedicated physician and researcher working in the field of genetic eye disorders. Reading the same line again. He is actively involved in teaching ophthalmology residents and fellows in the training program at Sick Kids. His research interests include carefully dissecting genetic retinal disorders, adopting various clinical and electrophysiological tools, and identifying new disease genes, characteristics, and mechanisms. He is also keenly interested in animal models of inherited retinal dystrophies. Our second panelist is Dr. Tomas Aleman. Dr. Aleman is an associate professor with the Shea Eye Institute of the University of Pennsylvania. Say that a few times really quickly, please. Where he cares for children and adults with retinal degenerations, hereditary or acquired, at both the Shea Eye Institute and the Perelman Center for Advanced Medicine. He is the co-principal investigator of a gene therapy trial for choroideremia. Most of the studies in which Dr. Aleman is an investigator are aimed to lead patients with these incurable retinal degenerations into clinical trials, as well as in the detailed characterization of patients, both children and adults, with these conditions. And then last but certainly not least is Dr. Stephen Sang. Dr. Sang is a professor of ophthalmology, pathology, and cell biology at Columbia University Department of Ophthalmology. Dr. Sang is an acclaimed clinical geneticist in the care of individuals with retinal degenerations and sits on the CRF Science Advisory Board, as well as our ICRN. Thank you to all 3 of you for taking the time to be with us today. Maybe we can start, if each of you wouldn't mind, just taking a couple of minutes to maybe say a few words about the work that you're doing, or any additional comments that you would like to make, and then we'll open the floor for questions.
Okay, can you hear me? Okay. So good afternoon. Thank you so much for inviting us. The work that I do is usually involve the characterization of diseases like choroideremia, both in animal models and in patients. And the ultimate goal is to understand these diseases, describe them as much as we can, and reach treatments. And I've been doing this for over 25 years. I was involved in the gene therapy trials that led to the approval of Luxturna, the RP65 LCA treatment, and now one of my main focus is choroideremia. Has been for a long time, more than 20 years. I actually know some of the people in the audience for over 20 years. But now we have the clinical trial that started in 2015 at the University of Pennsylvania and Harvard, and I am honored to have been selected to be a co-PI of that effort. We are still doing it. We are reaching, just completed the 5th year at Penn. We are still waiting for the Harvard group to complete the follow-up. The pandemic had to do a little bit on the on the delay of finishing up that study. So it's been a focus also to describe the disease. We had one of the largest, thanks to your contributions, because it's you patients who came to see us in the early 2014, 2013, and all the way through 2017, that allows to basically have one of the largest and most complete characterizations of the disease. And that study also continues. So the follow-up that involves many of you who come for follow-up to us is going to provide, hopefully, one of the most precise longitudinal characterizations also of choroideremia. And with that, let me let my coworker, my colleague here.
Hi everyone. I'm double masked, but can you hear me okay? Okay, good. So I do similar work as Thomas's. The difference being that I'm in Toronto and I have half the experience. So you can expect half of the quality of answers that you hear from Thomas from me. Having said that, I'm really grateful to be here. We are here to better understand what each patient with inherited retinal dystrophy goes through, and also try our best to help in your journey. I was first here in 2019, meeting in Philadelphia, and even now, as you grow in your career, you first try to become a good physician. And part of the development is to try to put yourself in the shoes of the patient, which I'm able to experience more and more this time at the conference. Thank you very much, and we'll see how this goes. Thank you. And I'll pass it to Dr. Stein.
In addition to participated in the Belgian trial, because I'm taking care of maybe about 50 choroideremia patients, and about 8 women are quite symptomatic. So we have been interested to look at women carriers in particular. Outside, that's my day job, and then my night job is we do CRISPR genome surgery in patients' stem cell line, organoids, and in mouse models. And there's a couple of those genome surgery we're trying to push it through FDA to get a IND.
Thank you very much for the introduction, gentlemen. So if you have a question, I would ask you either stand up or raise your hand, and one of the runners will find you with a microphone. Let's go ahead.
Craig Scheller, Associated Press. Mr. Biden, oh, I'm sorry, wrong. Sorry, get confused here for a second. Dr. Sang, good to see you again.
Hi, Craig.
It's been a couple of years. These CRISPR studies that have been popular, and I've read about them for a couple of years on different websites and news outlets and so forth. What exactly are those in relation to choroideremia, and do they not even have a relation to choroideremia?
So so the versatility, very versatile, much more versatile than any of the current platform in terms of gene therapy. But for choroideremia, as you heard from earlier from David Gam, the gene is relatively small. So conventional gene therapy, like some of the pioneer trial that Dr. Edelman is doing, may be sufficient. For a big gene, like you heard this morning, that maybe the genome surgery, CRISPR, is more versatile. And the different versions of genome surgery, the The original version is like a cut and paste. That's the one that the 2020 Nobel Prize. Some of the newer version is like a pencil and eraser. That's I get every month there's a new CRISPR technology, and you can say that maybe for easy to understand, you can look at some of the pharmaceutical website. So then BEAM is the BEAM base editors. It's like pencil and eraser type of CRISPR technology. And the most recent one is called Prime Editor. An example is Prime Medicine. So CRISPR now you can not only do pencil and eraser, you can also do it as a typewriter. So you do as a typewriter, you overcome some of the highly mutation specific. You heard from Dr. Gam that one of the limitation for CRISPR as opposed to conventional, just putting the gene, is highly precise and highly patient specific. The Prime Editor, when you get to do typewriter, you can type a paragraph. So it's like a pencil and eraser that you can only do one letter at a time. So those are all in development, but likely say CRISPR for choroideremia is not going to be to the stage that will be ready for in human trial, probably more than the next 5 years, because it's currently they're looking at the result from SEP290. So it's whether or not if there's if it turns out to be positive, then I guess it'll move ahead. It's still not clear that whether or not, say, for a small gene like choroideremia, whether or not using CRISPR genome surgery would be as efficacious as a more conventional. So because you know that in FDA, the older technology is easier to get approval. There's the barrier for CRISPR to get into human trial is much higher because, as you know, the Nobel Prize was only given in 2020 for a discovery described in 2012. You heard from Dr. Harbottle, the concept for gene therapy is 50 years already, right? Adding a gene in. So the barrier for CRISPR is higher to get into a human trial.
Hello, thank you all for being here. I'm probably going to not get my question out as clearly as I'd like to, but I'm going to take a stab at it. I feel like I'm missing a few components in kind of a wing-to-wing process, and I'm hoping you can maybe give me better descriptors to gain some of my clarity. Things that I think I know that I might get partially right. When we talk about DNA, and when I've given some talks, when I talk about DNA, I typically describe it as a twisted ladder, kind of in the helix, the twisted ladder. And when I speak to genes, I tend to say there are sections of that twisted ladder, and a section might be the choroideremia gene, for instance. And when I talk about that section of that ladder that is the choroideremia gene, I think of the rungs of that ladder as being, and I forget the specific name, I think it begins with an E, but they're the 4 letters, the A, G, T, and there's one other. And I have a deletion, so I'm actually missing one of those letters. So those are the descriptors I typically use. And I've learned from doing some Googling that, okay, the DNA, or actually the gene itself, is actually inside of chromosomes. So that's something that I'm trying to get conceptually in my head, that the gene is inside a chromosome, and the chromosome is inside the nucleus of the cell. And so when we talk about correcting, a cell via engineering or even sending a gene, you're doing that in a specific part of the eye, right? Like I've had the McLaren gene editing. that does not, and I understand that. I asked this question with Dr. Gam earlier. That does not correct the gametes that you would pass on to your children. So I guess I'm just trying to get a better understanding of how that meiosis process kind of works, such that where that correction would have to happen and how, such that it would actually pass on and the disease would be eradicated. So, and I'm not asking for real specifics, but just a better conceptual concept of that whole process of correcting the gene such that it truly is corrected downstream. So I'm sorry if that's such a convoluted question, but you can tell it's muddled around in my head a little bit.
Different. So you talk about we call somatic cell gene correction. Somatic cell means other than the sperm or the eggs. I think in different countries have different regulations. I think if you do this in Canada, for you doing any gene manipulation in the gametes, the eggs or the sperm, there's like 12 years of jail sentences. In U.S., as long as it's not using federal funding, it can be done. But there's no, as long as it's not federal funding. But typically, I think the National Academy of Sciences U.S. recommendation, and also typically in most of the U.S. and Western countries, would not do the germline, which is the eggs and the sperm correction. Would only do the in the inside the eye to be more limited. In fact, FDA is quite concerned, say,
We lost a second. Go ahead. I don't know what that is. I'll be right back with one. Here you go. Hang on just a second.
hello. So FDA is really concerned that if you do a gene correction inside the eye and then if it end up in the brain, that they probably will not approve so easily. So it has to be pretty local, at least for ophthalmology. I mean, of course, you would think of the other systems, sickle cell or spinal muscular atrophy, maybe that a little more generalized to the rest of the body. So generally, I think you can think of a different scale. The nucleus of the cell is like the solar system, and then maybe the chromosome is like the Earth. And then the gene is like United States, and then the base pair or point mutation is the spelling mistake is like Rochester or Woodcliff.
We have this work. Great. Let me just take a further step to that. Jeff, you had sort of alluded to gene therapy treatment in the back of the eye and where that vector, could that vector affect the gametes, the reproductive organs? I mean, generally speaking, if you want to affect the germline, so the sperm or the eggs, there had to be direct treatment of that area. And in fact, the gene therapy approaches that are taken today are really generally intended to localize that treatment into the retina, and for a number of reasons. One is to prevent systemic side effects or issues potentially by systemic distribution of that vector. Second of all, we want to try to localize and optimize how that gene therapy is affecting the retina directly. So by, if you were to give a systemic injection, those viral particles could end up in multiple different cells of your body, and by the time they get to your retina, maybe only 1% is left, whereas if it's injected directly into the eye, you're really maximizing the opportunity for that treatment to reach the cells where we need it most. So, and the FDA, I think, you probably would all agree with me, prefers that approach, that we want to limit that treatment to the area that's affected as much as possible. So there really wouldn't be any expectation of affecting the sexual organs by by retinal gene therapy. And in fact, we would certainly want to avoid that consequence, and the FDA would certainly not be in favor of a drug that was affecting the germline. So it shouldn't be a concern that we have. And again, based on the legal ramifications of research on this area, certainly not something that's being pursued aggressively by anybody receiving federal funding in the United States, and certainly other countries. The laws may change. Next question.
Thank you. I have a very personal question. Next to, I think, the normal progression of choroideremia, I have on top of it what I always call a shimmering, or like flashes in my visual field. And I've been to many doctors, and I always get the most wildest theories of what it is, like the syndrome of Bonnet, and like nerve vessels where blood drips on top of it and causes a discharge. I would like to ask you, do you know about this, what this is, these flashes? And how I always explain it is, it's like if you look in a very bright light and look away, like the shimmering that's there. I have that always on top of the visual field, which is actually more annoying than just the loss of vision, because it's so present in my sight that I was wondering if you know it, and if you know it, if there's anything that is known about it.
So yes, it's not a specific of choroideremia. It's actually something that we know it happens in most retinal degenerations at one stage in the disease process. The reason specifically in humans is not very well known. It's not very well understood. One of the theories is that the retina, as it loses photoreceptors, as it loses the light sensors, remodels, and we know that. In other words, the connection between the cell that sees the light and the cells that are next to it that have to do the first processing of the information to then pass it to the third neuron that contacts the centers in the brain for vision, there is an active process of remodeling, which for the most part is beneficial for vision as it compensates for the loss of photoreceptors. And that has been very well described in animal models. Less in choroideremia because of the lack of a perfect model for choroideremia, but it's very well known. And some of those pathways can reverberate. They can basically feed themselves in cycles. And one of the notions is that I actually take the flashes of light not as a negative phenomenon, which I try to explain to patients. It's a retina that is alive. It's a retina that is signaling to the brain in the absence of a proper signal. In my experience, it's actually typically patients who have better contrast between areas of good vision and areas where there is a blind spot. Those are typically patients who would report this type of symptoms frequently. And that may be the case in your case. I'm not so sure, but in choroideremia, it happens. Again, and it's localized. That's why you describe it as an area where that is probably close to the area where you have proper vision, and that's why it's also impairing in some ways because it's too close to the area that you're using for your daily life. The question that you didn't ask is what to do about it.
That was the next question, but go for it.
Of course, yes. There had been attempts to use medication, some of them not too benign, some anti-epileptic medication in some cases. I try to educate the patients about it. Like many things in medicine, once you know the origin of things, the cause of the symptom, you kind of take it in a different thing, from a threatening, basically symptom to a symptom that you have to cope with. One of the ways of coping with it is prevent triggers. So patients, some patients report that they have it all the time. And some other patients would report that they, at least even though they have it all the time, that there may be certain conditions where the symptom becomes more dramatic or worse. typically what you described. So staring at bright sources of light. So, and it's a very personalized thing. I sometimes depend on the low vision specialists that serve my patients to fine tune, for example, with filtering of light, the conditions that would kind of prevent at least the symptom from being debilitating. And it can be debilitating, I give you that. I usually, and I will ask my fellow physicians, I don't usually treat with medications, but there had been attempts to do that. I don't know if that answers your question.
Yeah, thanks. Thanks a lot.
Yeah.
So it also sounds a bit like a foreshadowing of the further deterioration of sight.
Not necessarily.
No?
So, not necessarily. So, again, it's a rewiring response and not necessarily a forecast of declining vision.
Okay.
In some conditions, if you go now and Google it, that's a different story. So there are certain conditions, retinal conditions, that are actually not genetic, when that symptom can be a presentation and it can be basically predictive of problem, not in retinal degeneration, not in slowly progressing diseases, such as genetic diseases. In some ways, the way that you can think about it is you have an amplifier of a signal in the inner retina that is amplifying something that should not be amplified normally. And the side effect of amplifying to serve your vision, to preserve your vision, is the presence of these kind of annoying flashes of light.
Thanks a lot. Can I ask a quick other question?
Absolutely.
Okay. Totally different category of question. You obviously all research in many different ways and in many different areas, but globally a lot of different things are being researched. What is the way that you share information with each other? And the question behind the question here is that I see within bigger corporates, I work in one, that data analytic platforms, for instance, become more popular, where instead of working for one pharmaceutical who has one economical interest, you put depersonalized data in a data analytics platform, and no matter where people are in the world, they can just pull that data for research. Is that something you see in your field as well, or are the big friends over there on the screen, the big pharmaceuticals, holding tightly control of the data?
Well, there are different types of data. There is a data that is within a clinical trial, and those are regulated by the rules of clinical trials. And typically, during the conduct of the trial, you're not sharing that data with anybody. I mean, with the scientists that are working on it and the sponsors, yes, you basically share the data. Especially trials where you're exploring safety, you have to be in contact with everybody, and but the public don't know about it. There is an effort by the NIH to basically foster sharing of data among scientists, especially scientists that are funded by the NIH, where you are basically encouraged, if not, I don't want to say enforced, but to have to share your data if the data has been produced as a result of a government-funded trial. And having said that, in our community, we are actually not many people, physicians working on retinal degeneration. You can basically email them in an email list, and the list is not that long. And we typically share with each other data. I cannot speak for others, but if my colleagues here, send me an email tomorrow and ask for data, of course I would maintain the confidentiality and the identity of my patients, but I would share information with them. Now, if the question is there is a structured database of sort for data mining, which is ideal, perhaps, noisy but ideal, such thing is in the works, but it doesn't exist. I'm not aware of that. And to achieve that, what we have done is do that in a disease-focused manner. And choroideremia has been one of them, where you basically address, a disease like a choroideremia or Stargardt disease, and then you standardize the way that things are measured, and you share the data. And that has happened already. They are for the simplest measures, such as acuity and visual field extent, things like that. They are actually published meta-analysis of papers that are already published by us, including thousands of observations. So it is happening.
But they're still on paper, right? And you share them within countries. Obviously, the best would be a global database, not being bordered by an American or a European regulation, right?
You're getting into more difficult answers there. So once you try to do something global like that, then things happen. More interestingly, recently, for example, the split between the UK and the European Union caused actually concern among researchers because of that, because there was a unionized approach to retinal degeneration. All of a sudden, then you have the issue of the split, and it doesn't exist like that, and it's not that easy. You get into the legal world very easily. So I don't think it exists as such. Absolutely.
Microphone. Hold on. Microphone.
It's one of the main barriers.
The question was, is this regulatory driven? Is that one of the main barriers?
It's one of the main obstacles, I would say.
If that were addressed, would it become? Sorry, if the regulatory environment, if that barrier was removed, because I'm just curious. You said there's something in the works, but it doesn't exist yet.
Right. So one of the things is that, for example, if I wanted to share my data with one of my colleagues from, I don't know, England, or I would have to have approval by my institution, approval. So it's a complex regulatory and necessary, I would say, especially in this day and age where identity can, very easily be compromised, as we all know. So it's a needed regulatory problem. But if I wanted to share data, for example, I cannot just tomorrow go and send all of the data from my patients to somebody or make that data available to a database. That's one of the problems. The second one is what data. So you can, gather data and make, data available to everybody and use AI, systems to look at your data and all of that. But the data quality is one of the other issues. So what data do you gather? You can gather, the height of people or the weight or whatever, and that may not be useful in a situation like this.
So within that, there would need to be a level of standardization.
Correct.
Also.
Yeah, which exists for the most part in our small field. For the most part.
Thank you.
Yeah.
I'm going to use the privilege of being next to the mic. I wanted to ask, for instance, when we take the presentation from Dr. Hume yesterday and about the two brothers, and when we see that there was a collaboration between different doctors and researchers to come up and from Canada, Spain, New York, and so on. Could we imagine possibly a model in the future, like a consortium for choroideremia, of coming up with a plan, a protocol of all the steps that we know that for the vectors, looking for the right vector, looking for, and could that be possible?
Maybe I'll take a step to, jump in first to say that that's part of the responsibility of the CRF, I think, or our role is to become the glue that brings our scientific community together. And so, part of what we've done over the years is to search out scientists. You heard Dr. Gam sort of jokingly talk about Randy Wheelock pulling on his elbow, but actually that story is 100% true. And I'll tell you that that's not the only scientist whose elbow he pulled on. Because we wanted to learn about what they do, but we also want to try to figure out how to connect that into the network more formally. And so that's led to a number of activities on our behalf, whether it's engaging with our community at large national or international conferences like ARVO and the like, where we can not only engage individually, but sometimes help to bring scientists together to talk about projects, or even have choroideremia-specific sort of peripheral sub-meetings at those meetings, which we've done once or twice. So that's certainly an opportunity. Another opportunity is for us to have, whether in the construct of this patient conference or as a separate what's the symposium. So the CRF certainly invites our scientists and clinicians to come and attend, and it gives them an opportunity to come to these sessions and meet you all, but also to sort of sidebar and discuss amongst themselves, whether it's in this conference or in the sense of a symposium, which we've had a couple of, to essentially lock them in a room, no pun intended, and let them have those kinds of discussions. And then third, and maybe Dr. Sang, you might want to speak about this, is the what you may have heard referred to as the ICRN, which is the International Choroideremia Research Network, which is kind of a virtual opportunity for, on a recurring basis, for scientists across the world to be able to interact and engage, potentially hear presentations from a member of the scientific community, to get feedback potentially on a project or an active project or an interested project, and to provide that kind of a forum for our community to, kind of get to the heart of what you're describing, which is, taking these really bright minds and putting them together to help kind of put fuel on the fire and accelerate our process towards treatment development. And anything you want to add to that?
The Choroideremia Research Foundation has done a good job to put scientists together. Right? It's quite similar in days that the cystic fibrosis, Huntington disease, which is called the Hereditary Disease Foundation, Muscular Dystrophy Association, like Jerry Lewis, to put the people, because the scientists typically has a pretty big ego, and then they but in this kind of forum, seeing a lot of them, they work at the bench, they may not actually interact with patients. So then when you come to the foundation, provide the avenue for people to come together and then level down this ego, and we'll actually work together instead of competing with each other. So I think, there's some success story. The Huntington, cystic fibrosis, I think those are some of the muscular dystrophy. And I think that Choroideremia Foundation, although Research Foundation is much younger, I think it has worked toward that goal to get people work together each other instead of competing or duplicating each other's effort. And more should be done.
There's a question back here.
Thank you so much for coming. I know it's a lot of travel and a lot of time, so we just appreciate all of our doctors being here today. I'm going to ask a question about carriers. A lot of the women that are here today, we have children, and we always advocate incredibly hard, and we pull hard and push hard, and we're here for our kids. And then at some point it dawns on you, hey, for many of us, we're carriers. And I know for me, I have a dad. You get concerned about your dad, and then you have kids, and you concentrate on them, and you ask all the right questions about the men in your family. But in terms of women carriers, I know the CRF is now looking at funding and supporting a research on carrier study, right? But in terms of you're all clinicians and you have patients, do you see a lot of carriers? You see their kids, our kids probably, but do you treat any carriers, and would you give any guidelines to those of us who are getting older or not so old, but are there things that we should be doing for us to improve our eyes?
Okay. So I think that's a well-raised point, because traditionally, when we were learning about basics of retinal dystrophy, it was, we were taught, choroideremia carrier, dirty fundus, normal function. That was how we were all taught when, maybe 15 years ago now. But things have evolved. So now we know that a proportion of carriers actually become manifest. So again, there are two aspects to it. One is, how do you define manifesting carrier? Do you define it based on symptoms that the patients present? Or when you examine carefully, as Dr. Sang may be able to address more in detail in the carrier study, if you look for symptoms or if you look for signs, how often can you, or how severe or how often can you pick up these symptoms, and what is the time lag between a manifesting male and a manifesting female carrier? So with regards to everyday treatment or advice for patients or children, so for instance, we focus mostly on patients who have symptoms. So even as I speak, I'm reflecting and feeling that if a mom is asymptomatic, should I be offering some sort of advice? I mean, I've not thought of it before, but for sure, if somebody has symptoms, if a female has symptoms, for sure, we advise regarding the same precautions as what we would advise for an affected male. But I would be interested to know what my colleagues would think. So would
The youngest woman that is quite symptomatic is under my care is in maybe 22, and of course I'm interested to see what Dr. Adamant's experiences also. But I think if they have a pretty good electroretinogram responses, I think the typical just put them as a group. I think they usually do get on quite well, generally with a few exceptions, into the 60s before they have symptoms of night vision or side vision issue. If the electroretinogram testing is still quite robust, at least in their 20s. So the people that are affected, women that have symptomatic in the 20s or 30s, the electroretinogram testing is quite attenuated at the initial presentation. Otherwise, the natural history is typically into the 60s. But we're interested, as Dr. Edwards was saying, that we want to see what looking at the woman carriers allowed us to see what the earlier stages that even the cell type is affected, allow us to think about what's the minimum level of protein that will be needed to, say, sustain a almost normal function in terms of therapeutics.
Okay. So there is the complexity of the X-linked carrier phenotype, so the disease expression, in the sense that it's variable, much more variable than the conditioning in the male, where we know things pretty well, or we think we do. It's a spotty disease, as you know, from random inactivation of the X chromosome. Each cell in the back of the eye will have activated or inactivated the good or the bad copy of the gene, and depending on that, which is very variable, among patients and even between eyes, you have more or less retina mass involved in the disease. In addition to that, depending on where the problems are, you are more or less symptomatic. And the typical symptoms, as Dr. Sand mentioned, could be, for example, night vision difficulties. And they can present typically later in life. But what is night vision? Actually, in most cases, what patients are complaining about has nothing to do with night vision, but more of handling, for example, incoming traffic lights and things of that nature, which is not necessarily night vision. And the reason for that is basically, in most carriers, is when the disease is patchy and spotty, affecting the central retina, central to mid-peripheral vision, which is basically, if you extend your hands in front of you, is that field of vision that is in between your arms. When that becomes compromised, then you become symptomatic in most cases. You can ignore symptoms before that happens. So what do I do? When do I get scared with carriers? When carriers have problems that are very close to the center. And that, again, the spottiness of the disease makes that a little bit less predictable than that in the affected male patient. When I see that, I do kind of enforce, and again, this is totally, we are not, it's not based on pure science, but for example, lutein, which many of you take as a protector, antioxidant and light protectant, I usually offer to carriers in that specific scenario. Depending on the imaging that you use, actually those changes can be more or less dramatic. Dr. San is actually conducting the study characterizing that in much greater detail than has ever been done before. But some of the changes can be quite dramatic, even in asymptomatic patients, in asymptomatic carriers. When I see them, I tend to be a little bit more aggressive. I recognize that there is an expense, for example, in buying nutrients. I recognize that, again, that there is no clinical trial supporting the use of this, but it's a pretty benign. One of the things that we do is, supplement with lutein. You have known about NAC, which is another antioxidant that is being tested for retinitis pigmentosa, another consideration. I would never do it with someone that doesn't have problems near the center of the visual field and retina.
Can I just jump in maybe with a follow-up question, Tomas? Sort of a leading question, I guess. We oftentimes get requests or questions from people about, this supplement and that supplement or vitamin supplementation. Should I take these things? Should I have my child take these things? In general, what is your approach when you're getting those questions from individuals? I know you just sort of mentioned lutein as one of those medications.
So we actually did a trial in 2002. Jackie Duncan at the time had joined our team to do her fellowship with us, and she's the lead author of that fantastic paper. And we characterize the level of something called the macular pigment. So when you take lutein makes it to the back of the eye. It's actually one of those nutrients that doesn't go almost anywhere in the body but the eye, and within the eye it doesn't go anywhere but the retina. And it happens that within the retina it doesn't go anywhere but the center of the retina, something called the macula. And the macula actually is called macula because of the macular pigment, which is made up of lutein. Macula means spot. So what we described at the time is that patients with choroideremia kind of behaved like the normal population, and that is there are people who have high amounts of macular pigment, other people have less macular pigment, like everything in life. There are tall and short people. And the other thing that we described was that it was possible to increase that amount in the retina by offering patients a certain amount of lutein by mouth. And there is very strong evidence that lutein is protective in general. For the general population, it's actually part of one of the supplements that is using in age-related macular degeneration as a protective. So I am, again, in the male affected male, I usually say, yes, go ahead and do it, because it's an extra, basically, layer of safety for the central cones. Cones die late in choroideremia. Cones, which are more numerous in the center of the retina, are the guys that are in charge of high spatial resolution and acuity. And I typically do it almost routinely. I can be blamed for doing that, but if I myself, since that study 20 years ago, I take it because I'm a carrier of certain genetic conditions. So I take lutein every day, and again, it's up to the physician to do that. Ideally, what would be ideal to do would be to measure, how much lutein someone has in the back of the eye, and supplement only those who have low levels. But that's kind of too much, probably, to do. I would recommend it. Other nutrients are less proven in choroideremia, for sure.
Excuse me. What is the nutrient that you take? I couldn't hear you.
Lutein. L-U-T-E-I-N.
Thank you.
L-U-T-E-I-N. Again, guys, this is not a blanket recommendation. I would consult with your physicians, and I see it as a benign thing that you can do at certain doses, and it's likely protective for the central cones.
And you can also supplement that dietarily, correct?
Absolutely. You can do it with spinach, three portions of spinach a day. Or anything. Yeah, I know it's a little bit too much, but actually the capsules are made of something. In most cases, the capsules are made of marigold flowers. So what you're eating is actually flowers. But you can supplement also with green vegetables, spinach, kale, whatever.
Okay.
Marigold flowers. Yeah.
Would you make the same recommendation about DHA and fish oil?
No. No, because there is always a concern. So DHA and fish oil has been used in the past, and my colleagues here to the right have been involved in that research in the past. In retinitis pigmentosa, specifically in a very specific form of retinitis pigmentosa, which is also X-linked, caused by, so the most frequent, which is a gene called RPGR. So it has been used for retinitis pigmentosa under the assumption with basis, scientific basis, that it improves the health of the photoreceptor cilia. So the antenna of the photoreceptor is kind of protected by DHA and fish oil. I'm not so sure that that mechanism is at play in choroideremia. And in choroideremia, there had been mechanistically, for example, what if lipid metabolism is involved in choroideremia? And there had been papers addressing that issue. What if the movement of fats, which is important for the retina functioning, is affected in choroideremia? And I don't know the answer to that. Because of that, I'm a little bit careful in over-supplementing patients with DHA. And again, I may be wrong. I would like to know if my colleagues have any thoughts on the subject.
So specifically for DHA, I fully agree with Thomas's observations. The one another pertaining question may be, like, we get patients coming with different types of antioxidant formulations, so we have patients coming with wild berry extracts, which are antioxidants. We have patients coming with a product called Retina Complex, which is a wild berry extract. We have some patients who are on zeaxanthin, which is another antioxidant. In our clinic and in our practice, we tend to be recommending lutein primarily, zeaxanthin, but some patients want to go natural. So they have these, different types of berry extracts, which they find from Amazon or other vendors. There's one called as Retina Complex. It is also a wild berry extract. So these are the 4 common types of antioxidants that we commonly prescribe.
So there's no evidence that antioxidants dietary can get into the eye, although there is a trial to this anti-Tylenol acetylcysteine is ongoing now for retinitis pigmentosa. Based on some of the animal models and some of the more current understanding of how cells die in retinitis pigmentosa may be applicable to choroideremia. That usually, if people exercise, at least in animals, you can force them to exercise daily. The lactate acid made from when you have crampy when you exercise, that's lactic acid. In around 2017, was found that retina, especially the epithelium, RPE, the major target for choroideremia, prefer lactate as the energy source. And when it gets sick, it is a scavenger. When it gets sick, then it would switch carbon source to energy source to glucose. When the epithelium kind of switch to glucose as an alternative fuel to make energy, then there's not sufficient glucose for the cones. And that is currently the quite acceptable theory why the cones that Dr. Ellerman mentioned, eventually they die. So generally, if people do a half an hour of exercise, feel a little bit crampy, you are making enough lactate, then the lactate would, you want the epithelium, the RPE, to use lactate as the energy source. You do not want the epithelium to switch to use glucose as an energy source.
So as a physician, you're recommending that people get regular exercise.
Yeah,
Stop me if you heard that before.
It's kind of difficult to hurt, right? But And it's probably cheaper than all the antioxidants you can buy from Amazon. And also, if you use lactate, it's more efficient. You actually mix less. Lactate is the preferred, or pyruvate. Lactate is the preferred energy source for the epithelium, in particular for the mitochondria. If you use lactate, then the oxygen radical made inside your cell is less. Lactate is better fuel for energy than actually glucose for the epithelium.
And what do you say about NAC?
So it's ongoing now. In fact, next week I have a meeting about NAC. But that's I think they do not include choroideremia patients in the trial.
We hear a lot.
NAC is the only antioxidant that, as far as I know, I think can get into at least get into the vitreous or get into the inside the eye. I think there's not enough evidence for any of the other antioxidants that you take by mouth get into the eye.
We hear a lot about research on choroideremia and related retinal disorders being done in the U.S., Canada, UK, Western Europe, but what about other nations in the world with developed economies, whether Japan, China, India, South Africa, Brazil, others? Is there any research relevant to us that you're aware of in those places or others?
I think for clinical trial become more international, so I think quite a number of patients in Brazil participated, say in the Luxturna approval and many of the gene therapy trials. And I think sometimes in other countries, I think sometimes choroideremia is lumped together with retinitis pigmentosa. Maybe that's they have a little bit less specific research.
From an organizational standpoint, we've over the years had contacts with physicians in some of the countries you mentioned. Obviously language barriers can present a problem, right? So we had a contact at one point with a Japanese physician who was trying to reach us in Japanese. We don't have a lot of resources internally to do that translation, so I'm not. That was several years ago. We haven't had continued contact with that yet. I know China, in particular, from a rare disease research standpoint, is kind of far behind the Western world, and that's a whole conversation for a longer time. But there's kind of a groundswell development of rare disease organizations and rare disease research that is starting to develop there. Other countries, again, we're from an organizational standpoint, we talked about this earlier with connecting scientists. We're certainly open to connect scientists from anywhere around the world who are interested. We've had representative scientists from a number of different countries that have connected with us. There's a clinician researcher in Brazil that we connect with on a regular basis. So we try. There's obviously some barriers and challenges to that. But if you know of any, send them our way. So the question was, is choroideremia more prevalent in certain parts of the world or certain countries compared to others?
So, if you look at prevalence estimates, there may be regional differences, but if you look at China or India, countries like that, they have huge population. So, there the limitation is accessibility to genetic testing to actually call it as choroideremia, as Dr. Sang said, because some of these patients are lumped together with retinitis pigmentosa or X-linked RP. So there will be regional differences based on population origins and mutations that are found in specific populations. But overall, choroideremia is not the rarest of rare disorders. So its estimated prevalence is 1 in 50. You know it more than me. 1 in 50,000 to 1 in 100,000. Recently, there are groups that have been looking at prevalences based on genome databases that are available in public domain. So there is a group, Dr. Dror in Israel, who is looking at genetic prevalences of specific types of retinal dystrophies based on publicly available databases like GenomeAD. And they also look at carrier frequencies, and also it's called as they look at, so let me try to put it simple. So they estimate disease prevalence based on variants that are known to be mutations in public domain. So these genetic databases have population-based control data from Caucasians, Asians, Africans, all different ethnic, all different races. The difference being that the amount of samples that are available is a bit skewed. So there is a database of close to 200,000 people in GenomeAD, but maybe around half of that are Caucasians. But there is still about 25 to 30,000 East Asians. So there are ways to now look at estimated prevalences based on these genetic databases from apparently controlled or healthy population, and this might help to determine carrier frequency in specifically in choroideremia, it being X-linked. It may help to determine carrier frequency in females in different populations.
Yeah, there is no reason to suspect that choroideremia is going to behave any different than the other ocular or retinal genetic eye conditions. And often, so more often than not, so the exception is actually that a disease will be located to a specific population. That will be, and there are exceptions. So there is the classical exception in our field is a poor island, and I won't say the name of the island, that was attacked by a hurricane or a big cyclone or whatever they call it, and killed most of the population, and basically by luck left a small group of people with a certain genetic mutation, and then they have a genetic eye disease that is characteristic of that specific population. Now is spread around the world because a mutation happens elsewhere. So more often than not, the exception is that a genetic disease would affect a particular population of patients. So more than likely, as access to genetic screening of a larger population of patients become available, we will know how choroideremia behave. But the prediction is that it's going to be the same. In the last 5 to 10 years, we have seen a growth, for example, in reports from China and India, which are huge countries. It's basically 1/3 of the population of the world, and the frequency of the mutations of even rarer diseases like livers, for example, liver congenital amaurosis, is pretty close to what we see elsewhere in the world. So we are humans, and we are exposed to the same genetic pressures that led us to have mutations here and there. And that's the prediction. Yeah.
May I ask, how many of you, the initial diagnosis was retinitis pigmentosa? So even in U.S., right, maybe the CRF need to do some better education for ophthalmologists, because even in U.S., the ophthalmologists are confused between retinitis pigmentosa and choroideremia. So you can imagine in other countries they are lumped together with retinitis pigmentosa.
Don't blame the ophthalmologists, actually. I usually defend them. No, because the term retinitis pigmentosa is a lousy term in some way. So it says basically 3 or 4 things. It says that a patient has a genetic eye problem. Second, that the patient may have early problems with night blindness. And particularly in kids, when you examine kids with RP, or even when you know the genotype, when you know the gene, sometimes you see nothing. Of course, if you're experienced and you have seen millions of patients with choroideremia, yeah, you can pick up the little pieces here and there and venture the diagnosis. And if you're careful enough and you have a family history that suggests X-linked inheritance, then yes, you can perhaps say that it's choroideremia, but RP is a genetic diagnosis, choroideremia is not. So RP basically genetic, some pigment not be there when you're a little kid, and nyctalopia, so problems seeing at night, and problems with your visual field. All of those are shared by choroideremia, and the hundreds of diseases that are under the umbrella term of retinitis pigmentosa. So don't think less of the physicians that made that mistake earlier in life. I always yeah.
While Corey's getting the microphone, I guess I would emphasize, maybe re-emphasize the importance of genetic diagnosis for patients.
Yeah, it's not, but you know, for clinical diagnosis, to aid them, Dr. McDonald helped us produce a PowerPoint several years ago, which we have on our Google Drive, which is available to any ophthalmologist or optometrist who wants it. And that is something that we do as a foundation, going to these conventions and trying to get that word out. So we're not looking down on the doctors, but we are trying to help them out.
No, I know. But I just there's a clarification. Because there is a sense sometimes, you know, what would have happened if I had the diagnosis earlier in life, and with that can come some sensation, you know, of blame of somebody. And I've been in difficult situations before making a diagnosis, and especially in children. When you see children, which I see all the time, things are not that clear cut unless you have a clear history, and unless you are spoiled like myself, you know. And all of us, we are spoiled physicians. We are academic centers, which top of the line imaging systems and electrophysiology. And it's easier for us to do that than the general ophthalmologist.
Any other questions? Well, this may be a first. I don't think we've ever ended this session early, but... Oh, we have one over there? Okay, all right. Thanks, we need the sighted folks to direct the moderator.
You were talking about studies on female carriers. Is that strictly unaffected carriers, or I personally am affected, so I don't know if you're doing trials or what's happening.
So far, the in terms of treatment, women are excluded in terms of treatment. But for so how to monitor them and how to maybe predict who is going to be symptomatic. So I work with Janet Sparrow, try to do different kind of imaging, how to do some kind of prognosis, and so it's all comers.
Yeah, how do we get involved with that?
I think you can just come down to Manhattan, and then we take a look.
Okay. Okay, I have a question that will help me to relieve sort of some feelings I've had about some exposure that my dad experienced as a young Air Force pilot. You may not know the answer, and I'm just curious if you run across folks who've had exposure to high levels of radiation. My dad had flown through atomic clouds, and this spontaneously shows up in me. So do radiation exposures, do you see spontaneous development of choroideremia? Have you seen it? Is it common at all? Is it a thing?
Your dad has a genetic confirmation?
No, this is nowhere in my family. I am the first. So he experienced very high levels of radiation, after which, point I was born, and I'm just curious if you see any correlation at all.
Not that we know of, but then is when you copy 3 times 10 to the 9 alphabet, just writing it, you make a mistake. That's how I guess people can get choroideremia. Just when you copy the DNA, and radiation just increases the error rate, but it's not particularly proven in choroideremia. I think if choroideremia patients are exposed to radiation, then you get more oxygen radicals. So it's, instead of say people make a mistake, I think in the rate is calculated known. I think maybe every time you copy your nucleus, your DNA, every time you maybe you make 100 mistakes, 50, 100 mistakes, but one of these mistakes you copy enough that you'll be in the choroideremia gene.
Yeah, I mean, we do see novel mutations in choroideremia, or at least we believe we have novel mutations where we have no family history of this, and then suddenly an individual has a genetic diagnosis of choroideremia. So, in the circumstance you could describe, that certainly could be a phenomenon, like Dr. Sang said, with when you're copying a genetic code and you have that many letters. If you miss one and the body's corrective mechanisms don't catch that, a spontaneous mutation can occur. So it could have happened true and unrelated to radiation exposure. The radiation, I mean, radiation exposure, high levels of it certainly do, have, an inherent risk of genetic mutation. So could the two things be linked? Hard to really know, but these phenomena are probably so uncommon and rare to see that downstream effect be an inherited retinal disease, that it would be hard to really link the two. Severe radiation exposure tends to cause a more sort of acute medical illness and even death, right? I mean, it can be tremendous. And I think that the most common issues that people end up having from radiation exposure are tumor formation, cancerous disease. Those are kind of the most common things. So, I mean, could the two things have been linked? I don't think you can say definitively no, but there's no real way to necessarily get to that conclusion.
Yeah, and so the clear answer is probably no. So the example is populations of Japan that were exposed to the nuclear bombs. So it does affect, and it causes errors in development of the embryo, but not necessarily mutations in the germline to get to you. I don't think there is any higher frequency of retinal degeneration in those populations, including choroideremia, than anywhere else in the world. And that's your unfortunate case example.